Okay, guys, we're going to go ahead and get started. And so excited to try something different. Excited to talk about this concept in our textbook is chapter 12, which is the idea of classes and objects. And the reason why this is exciting is because C sharp is an object-oriented language. Like if you look up Wikipedia on C sharp, in the first sentence it says object-oriented language, OOP, object-oriented programming. And so C sharp at its root is full of these things called classes and objects. And we've been in this class for 30 plus days and we haven't really delved at all into what that means. And so now, for the first time, in this class, we're going to be going into the fundamentals of classes and objects. Again, C sharp is kind of based on this. And so this is as important as any other lecture that we've had. Of course, we've covered all these programming fundamentals, loops and if statements and methods and fundamentals, all the stuff you got to have. But if you're coding object oriented, this is again fundamental to object oriented. And so I'm going to do this lecture a little bit differently. I'm going to be doing problem solving with my lectures as opposed to just giving you theory. We're going to give you theory and then solve problems with it. So the first problem I have here is in Notepad++, where we're going to be, creating classes and creating objects. And so, why? Why does C sharp have this thing called classes and objects? And it's important to understand what the benefit is here. Why do we need to learn these things? And it's the same answer, really, as I gave when we learned methods. When we learn methods, we learn that you write this little block of code, you write this thing called a method, you write it one time, and then you can reuse it unlimited, right? So you write a little block of code, and you can use it over and over and over. Code reusability is the answer to why we have these things called methods. And methods are a part of classes and objects. Classes and objects contain methods. And so really what we're doing is we're taking this code reusability, which we get when we implement methods, and we're just adding a little bit more to it. Now we can have methods that are reusable, but we can have these other attributes, right? Not just methods, but we can now have reusable attributes and reusable things. Okay, so a method is a reusable behavior. Okay, an attribute is a reusable piece of data. And a class is a reusable thing, which is really generic, but that's what it is. It's a reusable thing in software. So, you go back to chapter 2 when we kind of studied what I said was the bird's eye view of object-oriented programming. We've heard this term of class and object before, right? And we learned that a class, right? So very fundamentally, a class is a blueprint of an object. And an object is an instance of the class. Okay, so ground floor, this is what a class is. A class is the cookie cutter, right? A class is the cookie cutter. You're defining a shape. You're defining some code for reuse. Okay, that code, the class, the code has attributes and methods that are reusable. Methods are reusable, attributes are reusable, and classes, of course, are reusable. Okay, so a class is a blueprint of an object. Again, a class is the cookie cutter. A class is the cookie cutter. Okay, an object is the cookie. Obviously, you can have many cookies from one cookie cutter, right? So you have the cookie cutter, which is the class, and you stamp out a bunch of objects. Okay, that is to say, to be an instance of the class. right? An instance of the cookie cutter is the cookie. Okay, so that's how you have to think of classes and objects. Now, it is so generic, it's hard to wrap your mind around what is a class. But if you've ever taken an English class in school, you know what a noun is, right? Someone remind me in English language, what is a noun? Yes?
Person, place, or thing.
Correct. Person, place, or thing. So in the real world, we have people, we have places, and we have things. Any noun, any person, place, or thing can be a class. You take that person, place, or thing, and you put it into the code in this structure called a class. Okay, so you take a noun, a person, place, or thing, you put it into code, and it's basically getting that real world thing, that real world noun, into the computer. Okay, that is your class. It's a blueprint of an object, and any noun in the real world can be a class, right? A student can be a class. A teacher can be a class. A chair can be a class, right? A city can be a class. A person, like a teacher, an athlete, can be a class. Person, place, like a city, St. Louis, Houston, Dallas. These places can be classes. Or thing, again, I'm looking at scissors, I'm looking at a desk, I'm looking at a marker. Any one of these things, right? You just take the real world thing, you put it into code, you have a class. In our problem solving, we have a soccer player class. Okay? Now, again, I like to focus on the big picture a little bit at the start. A class is a single thing. A class is a single thing. So when you're defining a class, again, the cookie cutter, like the city. Okay, so you have a class called city. And then each instance of city is the object. So you have a city called Houston with a population, right? Attribute. The city might have a population attribute. The city might have a method called increase population, and a city might have so if you're Houston, you're probably calling the increase population because Houston's been going up in population. It's a popular place. If you're St. Louis, you're calling decrease population because St. Louis, the population has been decreasing for like 50 years. Okay, St. Louis used to have a much bigger population than it does today. Okay, so there's these methods called increase population, and there's a method called decrease population, right? These are actions that can be taken, and then population is an attribute of city, right? But then, so one instance of city could be Houston, one instance of city could be St. Louis, and that's a real world example. Again, I want to go back to the real world. You take these things and individual things, and you put them in the database. At the end of the day, these classes link up as tables in a database. Okay, and that's kind of where we're going. Okay, by the end of this C# class that you're enrolled in, okay, not to confuse it with a programming class, but this instance of this class, right, is you guys will be taking these classes and linking them up to tables in a database to store data. Okay, and I can kind of start this by showing you a class. And you can kind of take a glance, and if you just look at this piece right here, public class trip. Okay, a trip is a thing that you can do, right? You could take a trip, and then you've got these attributes like trip ID and destination and accommodations and the start date and accommodations and activities. Okay, all of these trips would then be stored in a database. So just kind of show you again where this is going. This is a C# class that I can show you that I've stored this trip in the database. So I can kind of glance ahead into my database and go into my trip log database, go into my tables, and here are my trips. And if I view the data, right, I just have one trip, and it was to St. Louis. I stayed at the Hyatt. Okay, so this trip is ultimately stored in a database table right here called trips. And when I launched the website that ultimately this is in, this website, you can see destination St. Louis, and we're showing the database data. Ultimately, there's a class that's storing the data, and here we can do things like add a new trip, right, on our website, so on and so forth. So these classes are individual things, and you can store a bunch of them in rows in database tables. Okay, that's kind of the big picture for where this is going. Now, probably looking at this code, at this trip class, this is kind of very modern C#. Okay, so looking at this, there's a lot going on here that we haven't learned, and there are many steps. There are many steps to get to this, okay? And I have to walk you through the steps, okay, to kind of writing a modern C#. In other words, there's different syntaxes, okay? There's different syntaxes for writing classes, and we're going to learn the different syntaxes. So what we're going to write isn't going to look exactly like this to start, but by the end of the class, it will. Okay? So again, kind of exciting topic because it's very real world. This is object-oriented programming. We're going to do some problem solving, and let's get started with that. So there's a little bit of theory. I'm going to create a Forms app, which is fine. Of course, it could be a Council app. Let me put this in the... Anything I put in junk just means I can delete it later on. Call this class demo. And this says create an application named Test Soccer Player. So my project will be Test Soccer Player. Click Next. Create. Okay, so here's my solution. And looking at this problem, it tells you very clearly the name of our class. Again, a class is a noun. A class is a noun, a person, place, or thing. Ultimately, you take that noun and you store it in a database. Okay? So a soccer player, like you would ultimately have teams of soccer players. Anybody watch the St. Louis soccer game on Saturday? The St. Louis Soccer Club played their first match. I didn't watch it. I'm not. We do have a soccer team. They played their first game. They won. So we're gonna make an individual soccer player. Ultimately, you're gonna store these soccer players in like a list of soccer players on a team. Maybe you might have a team, but for right now, we're not that complicated. We're just gonna have individual soccer players. Okay. Now to create a class, everyone zone in. Go stand up, please, and get a drink of water. Okay. Go, please stand up and go get a drink of water. Here's how you start to make your first class. Now, in the real world, classes are organized in a folder, okay? So you might create a new folder here, but for right now, that just complicates things. So I'm not going to put my classes in a folder to start. So I'm just going to right-click the project. Remember, this is the solution. This is the project. So notice where I'm clicking, solution and project. So I'm going to right-click the project. I'm going to go down to the add button. And notice right off of the add, there's this thing called class. Okay, we're making this class for reusable code, and ultimately these classes, these instances of the classes will be stored in a database. Okay, that's where you wind up going. Now it tells us the class name should be soccer player. Okay, so I'm just going to name it soccer player. Now classes end with a .cs. If you don't put it there, Visual Studio will put the .cs on there for you. So I'm going to click on add. And it will add a C# class to your project. And why it's spinning, I don't know. it's really not that much work to do, but my computer wants to pretend like it's working hard. Come on, Visual Studio. Keep up. Whew. Okay. You now see that there's this new file called soccer player. First thing to notice, it marks our class with an access modifier that we haven't talked about. What are the access modifiers we've talked about so far? Public and private. Okay, we have not talked about this thing called internal, okay, which is a different access modifier. It is traditional for your classes to be marked as public. So the first thing that I do here is I mark these as public. Internal somewhere in between the two. There's private, which is locked down. There's public, which is wide open. Internal somewhere in the middle. We don't have to worry about it for right now. What we're going to do is just mark our classes as public. Yes?
How many of those are there? Isn't there like static also?
Okay, so access modifiers are public, private, protected, and internal. So those are your 4 in C#. Static is a different keyword. It does something different. So static is not an access modifier. Good question. But yeah, there could be a whole chapter on access modifiers. But I keep it simple. Classes, make them public.
So we'll only use those 4 though?
Those are going to be the 4 that we use. Yep. Okay, so let me zoom in on my code here because why am I so zoomed out? Classes are blueprints for objects. So we're creating the cookie cutter. We're not creating our objects yet. We're creating the cookie cutter. Classes are composed of 2 things. Classes are composed of attributes and methods. Okay, attributes are ultimately our data, and methods are our behaviors. Okay, events, a lot of times you'll see that events are methods. So I don't really put events as a third thing here because events are methods. So I just say, look, classes are built of 2 reusable things. You have reusable data and you have reusable behaviors. Okay, so our cookie cutters are going to have reusable data and reusable behaviors. And so when it comes to a soccer player, like what data do we want to store in our application? Okay, I mean, soccer players, you could store all sorts of things. Their height, their weight, their number of goals scored in their lifetime, their speed, how fast can they run the 100, how fast can they run the 200. There's like unlimited data that you could store about a soccer player, but that doesn't mean you store unlimited data. You just got to say, this is the data that's important to my application. Okay, so luckily this problem says the player's name, the jersey number, and goals scored, right? So this problem tells us what data to store, and it even tells us the data type. So let's kind of start by calling, now it uses a keyword here called properties, okay? And I need to explain what a property is versus, an attributes. You might also call it a property. Okay, data attributes, properties, they're used interchangeably. So we're creating variables here we're not putting data in the variables. That's important. In the class, this is the cookie cutter. We don't know the soccer player's name at this point. So we're not putting data in here. We're just creating the cookie cutter so that you can create a soccer player that has a name. Now, part of the challenge of programming is learning that, well, ultimately we're working with your data here. Some people might call it a property, which means one thing in programming. You might call it an attribute, which means another thing. Instance fields means something very specific. Again, instance fields, this is the data that each soccer player will have. So I'm going to also mark it as private access modifiers. So our variables have not had access modifiers until now. Think about every variable you've ever created in this class, you never had an access modifier until now. So when you have what are called instance fields, you have these classes, and these classes have data in them. Now our variables have access modifiers.
What's the difference between, like, if you're going on the actual project and right-clicking and then opening up a class that way versus just typing out public class soccer player?
One more.
Like, you know how when you opened up that class for soccer player, you right-clicked on the...
I right-clicked here and said new class,
and you went through there.
add class.
So what's the difference between doing that and just typing public class soccer player within the namespace?
Well, it created this file called soccerplayer.cs.
So it won't create that if you just type it out.
Yeah, I mean, I don't know where you would type it. So here in the form, and if you view code, notice here there's already a class. And so what this does is it creates a separate file called soccer player. Now, you could put a class right here, is I think what you're saying. Couldn't you put the class somewhere else? But there's a rule in coding is that there's one public class per file. Notice there's already a public class called form1. And so because I want to make my class public, I'm not going to put it in that same file. Because there's a rule that's one public class per file. Okay, so I'm not going to put my classes here. Okay, and actually for code reusability, this is kind of the best way of doing it. You're making its own standalone file for that, you know. Okay, string player name. Okay, so here we have this variable, and we're going to call, remember our variables so far? They're called local variables, which means they're inside of a method. Or we had these class variables, which were inside of a class that we defined right here. So we defined like class scope was what we called it before, and then we had these local variables. Okay, these are called instance fields, and just like the practice is to make our classes public, the practice here is to make our instance fields private. Okay, so classes are kind of wide open, but our data is very secure. Because we mark it private, that is the most locked down that you can have. It's also the convention to have your instance fields start with an underscore. So that's the convention we're going to use in this class to identify that this variable is a piece of data about one of our classes. So the reason they're called instance fields is this. I mean, ultimately, this is the data. You're going to create a soccer player. Each instance of soccer player is going to have a unique name. Zone in on that for me for a minute, okay? Each instance of soccer player will have their own name. So that's why we call these instance fields. Each instance is unique. Everyone with me? Each instance of our class will have their own player name. Yeah, so when you put the underscore there, anytime you see an underscore in our code, we're going to, that's an instance field. So it's a convention. It's a naming convention.
Is that why those quick fixes kept saying instead of doing this, it just does an underscore there?
Maybe, I don't know. I'd have to look at it. But this is just a convention that's fairly common. Instance fields are identified with an underscore. Okay? So again, kind of going back to the problem, we've got a player's name, a jersey number, and a goal scored. So following that, private int underscore jersey number, private int underscore goal scored.
There's still assists.
Is that what it was? Oh, there's still assists
Yeah.
and assists. Okay, so all we've done is created these things called instance fields. These are our data that each soccer player will have. Now we have to create ways for putting data into these. We have to create ways to put data into these instance fields. Remember, we're not putting data in here. If I wanted to put a default, I guess you could do like the default is like empty, right? You can assign a default value like that, but we're not going to do that for right now. We're just going to keep that off. I'm going to teach there's many ways to put data in. Let's start with this. As you're learning these classes and objects, it can really be broken down to this. It's all about putting data into these things and getting data out of these things. And by these things, I mean the instance fields. Okay? We're going to learn like 3 or 4 ways to put data in, and we'll learn multiple ways of getting data out. Right? It's all about the instance fields. Right now. It's all about the instance fields. So the first thing is create the instance fields. Now we have to create ways for putting data in and pulling data out. And the first way that we're going to learn to put data in and pull data out are with our methods. Okay? And this is, if you studied a Java class before, because Java is older than C#, this is the old school way of doing this. Okay? And the reason I'm teaching this is if you ever go get a job with Java, you will probably see this. Okay? And there are lots of good jobs out there with Java. Okay? So you write these methods that are called accessors and mutators. Okay? Mutators modify the instance fields. Of course, accessors access the instance fields. Okay? So you want to put data in, you use a mutator. You want to pull data out, you use an accessor. Okay? So let's start by writing some accessors, and I'm going to write all of them all at once. So I'm going to write a method. Now that we've studied methods, we can understand a little bit more about our methods. Notice our methods are public. I'm going to return the player name. I'm going to call this get player name. And I'm going to return player name. Okay, so this is a method. And all that method does is return a piece of data. Pretty simple, right? This is called an accessor, It's called an accessor because it gets a piece of data. Right? Now, I'm going to do the same thing for jersey number. Public int get jersey number. Now, here's an arrow syntax that does the same thing. This is actually, if you've been reading the book, and hopefully you've seen some arrow functions, and this is essentially doing the same thing. Okay? So these are 2 different syntax for doing the same thing. The arrow syntax is shorter, so of course a lot of people like the arrow syntax. Get goals scored. Notice the convention. There's no parameters, and it just returns the instance field called goals scored. Okay? So these methods have no inputs and one output, and that one output is the instance field. So we're creating a way to read the data. Last one. Public int get assists, arrow assists. I now have what are called 4 accessor methods. These are very traditional, and you see them all over the place in Java. I don't know that Java has the arrow syntax, so you see a lot more of like this. Okay? That syntax. And those are the first 4 methods, and then the next 4 methods we need to create ways to modify our instance fields. It's all about the instance fields. It's all about the instance fields. I grew up in the 90s and there was a song called It's All About the Benjamins. Anyone ever heard that song? It's All About the Benjamins in the 90s. Anybody? Huh?
You ever seen the movie?
Never seen the movie. Okay? Today it's not all about the Benjamins. Today it's all about the instance fields. Yes?
With these methods, can you still pass in parameters?
No, these methods do not take any inputs.
I know, but could you if you wanted to?
I mean, you could do whatever you want.
Okay.
You could do whatever you want. But it's not traditional, right? It's not traditional for them to have. Now, notice the naming convention is that you start with the word get, and then what are you getting? What piece of data? Okay, so I'm going to now, if these are the accessors, these are 4 accessor methods. I'm going to write 4 mutator methods. Okay, so I'm going to modify these. Now, my mutators, again, our methods are now public. Up until now, our methods were private. Now our methods are public. Our instance fields are, in fact, private. And our mutators and accessors are public. Now, notice on our mutator, there's no return data type. We're not returning any data here. And actually, because this is so common, this is exactly IntelliSense. Just let me tab this in. Let's talk about what this is doing. Our naming convention here is set instead of get. Okay, we have one input, which is going to be passed in. We have one input, which is our player's name. And notice what we're setting. We're setting underscore player name equal to the parameter player name. So we're setting a value on the instance field. We're setting a value on the instance field equal to the value that's passed in. Okay, when I learned this at first, like I literally just memorized the pattern here of like what, like, okay, on the accessors, there are return data types and they have to return a piece of data. On the mutators modify data, so they're with the set, right? Set player name. And they return void, so there's no return. Let's public void set jersey number. Int jersey number. I don't know that you can do. So here's the arrow syntax for that one. Right? Just it doesn't save a whole lot of keystrokes, just the curly braces. Doesn't save a whole lot of keystrokes. So literally line 30 and line 35, they do the same thing. They allow one input to our method called jersey number, and we set the instance field equal to the parameter. And, you know, I believe Mr. Guggeman would agree with me in that, you know, you wrote Java for many years, and so setters and mutators
all over the place.
all over the place.
Yeah, you always have. Java was a little bit different. We had a different class by itself, a different file that you get the getters and setters in. But anytime you're passing data back and forth, it's going through a getter and a setter.
Yep.
You'll hear people talk getters and setters a lot.
Yep. So there's a lot of value towards learning this because, again, it's good for multiple languages. Let's say set goal scored. Get that out of the way so you can get it all in one line. Okay, so now we have 4 instance fields. We have 4 accessors. We have 4 mutators. And now what do? We have now created our cookie cutter. Now we got to create the cookies. Okay? We can now create a bunch of soccer players. We could create 20 soccer players and put them in an array. Okay? Or you just create 1 soccer player. We'll start with 1, then we'll create 2, and we'll create 3, and we'll put them in an array. And that's kind of, and then, and then you put them in a team, which is another class. But that's kind of down the road. So now we're kind of back at the form, and we got an empty form. Right? So here's our form. And I'll just put a button on here, and so we can have a create player button. We'll call this button create player. Create player, bada bing, bada boom. Okay, we have a button click now, and show you the syntax for creating an object. Anytime you see the keyword new, flag should raise in your brain and say this is creating an object. The keyword new is creating an object. Okay? So there's a couple of things going on here. We're creating, on line 12, the first thing is a soccer player. Now, before we had like an int age. Okay? This was our variable. And you would do something like this, right? It's the same things going on. What is the first piece of, the first word is int? That's our data type. Same thing on line 12. Our data type is soccer player. Remember, integers are what are often referred to as primitive data types. They're kind of built into C#. Right? Int, float, double, char, blah, blah, blah. Those are all built into C#. Soccer player's not built in. Okay? That's called a reference type. A reference type, aka it's an object. It's an object type. Okay? It's an object type. So our data type is a type. When we're creating a class, you're creating a data type. So we're creating a data type. The identifier is player, right? You get to name it. It is a programmer-defined identifier. Okay, you could call it player. You could call it player 1. You could call it tofu. Whatever you want to call it. Okay, you call it something that's meaningful. Okay, and so I'll just call it soccer player called player. Okay, giving it a meaningful identifier is important, as we've touched on many cases. Then we have an assignment operator, the equal sign, just like we had the equal sign before. That's an assignment. We're initializing it to a new soccer player. Now, let me tell you what this does. When you have a new soccer player, this actually does something. It sets players. Player has a name of null. Player has goals scored of 0. Player has assists of 0. And what's the last thing? A jersey number. Player has a jersey number of 0.
Is it 0 or null?
If it's an integer, it's 0. If it's a string, it's null. If it's a double, it's 0.0. Okay, so on line 12, when you create a soccer player in this way, all of its instance fields have default values. Those values are 0, 0.0, null. It's basically empty. It's like an empty object.
What about Boolean?
False.
False.
Boolean is false, and like a char is some weird empty char string character, whatever. Okay? So when you create a soccer player, now, what do you know about parentheses? When you see parentheses, it should scream method. This is a method call. So on line 12, we have a data type, we have an identifier, we have an assignment operator, we have the keyword new, which screams this is an object, and we have a method call. Can everyone see it? The method call. Wake up. Shake your head, yes. Just shake your head, yes. Yes, thank you.
Wow.
Everyone can see the method call. Okay, that's where my cursor is right now. This is calling a method called soccer player. I want to invite you back into the soccer player class. Is there anything here called soccer player? There is no method called soccer player that we see, but there is. There is a method called soccer player. It's actually not a bad idea to code it. It looks just like this. Okay? There is a method automatically given to you for free when you create a class. This method is put in there by the C# compiler. Okay, C# puts this in here. This method is given us a name, but it's just a method for free. You don't have to code it. It's not a bad idea to code it, especially for beginners. Okay, for beginners. Now this, you'll notice right away how it says one reference. You see that? Why is there a reference? Well, because we're calling that method right there. Okay, so point is, that's a method call. You didn't have to code it for it to work because you get it for free, right? You don't have to code it, but if you code it, you can see that it is in fact coded. Now here's what we'll do. We'll say player. Does anyone have a favorite soccer player? Now if I say player.set, notice these are my 4 method calls. So now that I have an object, I can set the player name, I could set the player age or whatever, the player goals scored, I could set the jersey number and the player name. Messi. What's his full name? Lionel Messi. Forgive me, I'm not a soccer fan. It's just one N, one L. Excuse me. Lionel Messi. Let's do player.set. Jersey number. Anybody know his jersey? Notice set player. Let's go with 10. Okay. Lionel Messi is a string, so I got to put it in quotes. Set jersey number expects an int. Well, there's no quotes on an int. You just pass it right in. Set player jersey number. Let's do player.set goals scored. Of course, he's the greatest of all time, right? So let's just assume he's got a lot of goals scored. And, of course, he's also the greatest of all time, which is, I'm sure, a heated argument. But let's just say he's got a lot of assists as well. Okay. We've created an object, and we've now put data into our object. We could create 100 soccer players, and they all have the same methods. Code reuse.
So is this kind of like how, I guess, like, game coding can go into play as well?
Yeah, I mean, if you're coding games, of course, you'll be using classes and objects. You know, I think it's Unity that uses C#. For anybody that's dabbled in some game development, you will very quickly, if you're coding in Unity, be creating classes and objects. So absolutely. Why? Why do we create classes and objects? Code reusability. Code reusability, code reusability. Okay, now, yeah.
So you know how like it's a storage thing, so like you put like multiple, let's say, players in them.
Yeah.
Is pressing them and just gonna like siphon through them? This is the first set you put in, and then the second, or do you have to call them up specifically? You know, because like I can go put, let's say, Ronaldo's info next, but
Yeah, good question. So the question is, hey, if you actually have a bunch of players, you know, like right now we just have one player, and you know I want to start with one player. But now if you want to add another player, you know, how do you have Ronaldo, right? So I'd say soccer player 2 is new soccer player. What? Is that kind of what you were getting at?
Yes.
Okay, now I've got player and I've got player 2, but let me just finish with my one soccer player before I do a second, okay? So now we've got one player, we've got 4 pieces of data set, and I'm just going to output that into a label. Label result.text equals string interpolation. Player name. Player dot get player name. Player jersey number. Player dot get jersey number. So I called methods to set the data. I'm calling methods to get the data. And I'm just formatting it in one label using the syntax. So I don't need a bunch of different labels. Player goals scored. Let's set the assist to 1001, 101, whatever. Player goals scored. Player dot get goals scored. These are method calls. Player assists. Player dot get assists. Bada bing, bada boom. Okay. We're not seeing the benefit of creating this yet because we just have one instance of our class. We have one cookie. We have one player. Okay? And we put data in and we pull data out. And if I run this and I create my player, okay, it's really not anything fancy yet, but now this is the template. We have the cookie cutter for creating a bunch of players, and ultimately you store each player in the database. Like that's where it's going. That's where it's going. Okay, so let me put in a little line break, and let me ask for questions. What other questions do we have around what we've done so far?
Put your line break and that's close.
Atticus.
I'm trying to find it in the code. So when you're doing the accessor methods, do you have to do the strings as return as opposed to like the arrow function for the others?
No. Good question. I could have used arrow functions for all 4. I was just showing different syntaxes. You could have used arrow functions on all of these. And arrow functions save a couple keystrokes, is
So
what
you
it
also
is.
use return on all the ends.
Yeah. 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 You could refactor this to an arrow function pretty easily. Yep, still works. Other questions? It's all about the instance fields. Instance fields are just variables that are associated with an object. Right? And each instance of our soccer player will have its own unique player name, jersey number, goal scored, and assists. Now, could there be 2 different soccer players with the same name? Sure, just like there could be 2 students with the same name. But they're stored separately. They're stored in the database separately. They're stored in the program separately. Yes?
For notice purposes, you said an arrow function. What would be like a good description for that?
An arrow function is a shorthand syntax. For creating a function. Now, just to flush this out, because it was asked about player 2. So here's player 2. Right? Here's player 2. Let's go ahead and, set player 2 dot set player name. Who's the other good soccer player? Pele. What's his first name?
I have no idea. There's no P-E-L-E.
All right. Maybe that is his first name.
Cristiano Ronaldo.
Ronaldo. Cristiano. What?
I'm not a spell it.
Pele. Pele it is. Player 2 dot set goals scored. I mean, he's good, but not as good. So we're going to go 900. Goals scored. Player 2 set jersey number. We'll just say he's jersey 23. Player 2 set assists. He's got 300 assists. Okay. Hey, we're reusing those methods. We wrote the methods once. We're using them multiple times, right? We wrote the class once, and we're using the class multiple times. We're reusing our code, right? Now that we have player 2, let's go ahead and to our label, let's just append a couple of line breaks here. Okay, now I'm going to copy this underneath and paste, and I'm just going to change this to player 2, player 2, player 2, player 2.
And now it's just pulling all.
Now it's pulling the instance fields from player 1, and now it's pulling the instance fields from player 2. Now, bug, is that
You didn't put the plus equals at the bottom.
plus equals instead of just equals. Okay, now we've got 2 cookies. Each cookie has unique instance fields that we've set their values with mutators, and we got their values with accessors. Awesome stuff. I'm going to pause.